going to talk about the interior angles of a polygon. And first, let's talk about what a polygon is. It's a closed plane figure, and it's going to have 3 or more line segments that intersect only at their endpoints. So here's a triangle, here's an arrow, there's a whole bunch of different kinds we'll talk about in a few moments. But these are polygons. Now, this is example of non-polygons. These are intersecting at more than their endpoints, and then we've got the curves on these, so they're not polygons. If you look down here, you'll be familiar with some of these words. If it's got 3 sides as a triangle, 4 quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, 12 is a dodecagon, and anything else we just say 11agon, 13gon, 14gon. They actually have names, but we don't bother to learn those. All right, we have a formula. The sum of the interior angles of a polygon, meaning all these angles right here added up, will be n minus 2 times 180. So if I have this 1, 2, 3, 4, 5-sided figure, this would be considered a pentagon. It has 5 sides right down here. And the formula would be n is the number of sides, 5 minus 2 times 180. 5 minus 2 is 3, and 3 times 180 is, let's see, 3 times 180 is 540 degrees. So any pentagon is going to have 540 degrees when you add up all the sides. Now you may wonder why this works. If you were to take any of the vertices of this pentagon and create all the diagonals, like from this point right here, there would be a diagonal that goes from one vertex to the other. And that would be all the diagonals possible. You would have 1, 2, 3 triangles. And we learned earlier that every triangle has 180 degrees. So this pentagon is going to have 3, that's 5 minus 2, times 180, 540 degrees. Now here is a hexagon, 1, 2, 3, 4, 5, 6. So S equals 6 minus 2 times 180. So that's 4 times 180. 4 times 180 is 720 degrees. And so it works for all of these. And if I wanted to look at this, and this is not something you would have to do, pick one of your vertices and create all the diagonals from it. And you'll see why the formula works like it does. 1, 2, 3, 4 triangles. 4 times 180 is 720.